My father, Roger Pratt, was diagnosed with young onset familial Alzheimer's disease, and he died on New Year's Eve 2024. I definitely remember getting the first diagnosis of Alzheimer's and that being like, what? Alzheimer's? Like, never. And then the next thing of, oh, actually, it's this really rare type of Alzheimer's and it's genetic. I remember the feeling afterwards because I couldn't stop crying.
There are 1 million people in the United Kingdom now with dementia, and that number is set to grow as the population ages. Queen Square is integral to the story of advances in the fundamental research into dementia. Our research is built on long-term partnership with patients and families, perhaps particularly in familial Alzheimer's disease. We're the National Centre for Families. We set up the very first familial support groups, and those families have allowed us to track the changes that are the very earliest onset.
He loved life and he loved people, and he was so interested in taking part in research from the point of diagnosis.
Yeah.
Taking part in research means a lot to me. When your family receives the diagnosis of a rare disease, to find out that it's genetic, and to watch your loved one deteriorate from the disease, I think those are loads of really good reasons to want to do something. When you come together and take part in research, straight away you feel less alone.
Most of Alzheimer's disease is not inherited and passed down through generations, but rarely, perhaps less than 1%, is. And those families have led so much in terms of what we know now. Following individuals from pre-symptomatic disease all the way through is the only way we can understand what influences progression in diseases like Alzheimer's disease, frontotemporal dementia, Huntington's, and that arc of trajectory that is so important. Brain scans, for example, have given us a window into seeing what's happening in some of these diseases, even before there's any damage to the brain. The ultimate goal, the ultimate prize, is to intervene pre-symptomatically.
The earlier we can intervene, the more effective those treatments are likely to be. In my lab, the uniqueness of our approach is because we can't easily take brain biopsies for our research. So what we do instead is we grow stem cells in the lab, which are a blank slate. We can take those stem cells and turn them into brain cells that we sometimes call mini brains. And by doing that, we can compare those cells to understand the very first things that are going wrong in the brain. The importance of that is we can then think about developing treatments that intervene at each of those stages.
Everything that we're seeing now, for example, the new therapies for Alzheimer's disease, first treatments ever to have shown the ability to slow disease, they're built on 40 years of research.
One of the most important moments in dementia research was the identification of the first Alzheimer gene. With my colleague, Dr. Martin Rosser, in the late 1980s, he and I started to work with families with Alzheimer's disease, and the largest family, the Jennings family, had mutations which we found in the amyloid protein. Finding that definitive mutation focused research, and it also guided drug company research to the therapies we've now got. When you look back on a breakthrough like that, what's been really important from that history onwards has been the building here at Queen Square of a clinical trials unit which puts these new therapies to use. So we've now got the first treatments.
I'm really optimistic about where we are in dementia research at the moment. And my hope is over the next 5 to 10 years, we will really see an acceleration in terms of our understanding of the disease and the development of new treatments for patient benefit.
I think we're in the most hopeful time since I started taking part. It feels like there's some light in the darkness.